Everyone, we're moving right along in our angles unit with lesson 2, which is how to measure angles. So we've already discussed angles and we know that they're measured in degrees. And up until now, we've kind of just really learned how to recognize some basic rectangles. Right angles, are 90 degrees. Straight angles are 180. And then we also talked before about obtuse angles being greater than 90 degrees. But less than 180. And then we also talked about acute angles, which are less than 90 degrees. And so how exactly though can we find the exact measurement of these angles that aren't 90 degrees and aren't 180 degrees? So degrees are considered a unit of measurement. So like I said before, angles kind of combine geometry and measurement together. And so we have a unique tool that we use for this. It's not a ruler, it's not a measuring tape, it's called a protractor. And so I have a protractor here, and this is a pretty typical protractor that we would use if we were actually in the classroom right now. And you can see there's a few elements here that I'm going to point out. There are two bands of numbers going across the protractor, and the reason for this is so that you can use the protractor anyway. Most protractors are like clear plastic see-through so that you can easily read the angle through the protractor. And the reason for the two bands of numbers is so that no matter which way the angle is pointing, when you lay the protractor on it, you can measure it. You don't have to like flip the protractor a special way, which is a good thing, but it can also be a little bit confusing. So we're going to talk about that today, and we're going to do some examples. So this is where you kind of just have to combine your background knowledge about acute and obtuse angles, and then that will help you with figuring out which band of numbers to use. And like I said, we'll do an example of that in a little bit. The other really important piece of a protractor is this right here, this center point, okay? We'll use that later. But this center point here is where you are actually going to line up your angle, line up its vertex, and then you can actually kind of see here. So actually I can, how come it won't let me draw on the protractor, but I can draw off the protractor. Well, it's okay, because we're going to use this in just a second. So we have our center point, and we have our numbers, and all these tiny little lines up here, okay? So you might think, well, it kind of looks like a ruler, right? It's like a bent ruler. These are representing each degree, okay? So if I were to, come all the way down here, there's 0 here, and then this tiny little line, this would represent 1 degree, all right? So degrees aren't very big. They're pretty small actually. And then this one is nice because it's so kind of similar to, metric units, how it goes in the by the tens, because if you remember looking at the meter stick, like the meter stick, went in groups of 10, just a lot easier. And so the protractor works in a similar way. And so these little bit longer lines represent, the fives. So this would be 5, this would be 15, 25, and so on. And then the smaller lines in between are individuals. So before we get started, though, we're actually going to look at one more type of protractor. And this one you don't see too often, especially in elementary school, but you may see it in middle school. Eventually, and this is just a full circle protractor. So remember, our last lesson we talked about how a circle is 360 degrees and all angles, are a piece of a circle. And so this is really just two of the previous protractors combined. And you can see that out here, we do have a total 360 degree measure. So this just allows us to measure angles that are more than straight angles. Again, if you remember from our last lesson, we talked about that 270 degree angle that was 3/4 of a circle. You could easily measure that with this protractor. See, there's 270 right here. You could even measure an even larger angle than that. So let me, oh, I actually took that off. Let me get my pointer out because then this will make things a lot easier. All right, so, and we'll do this with the smaller protractor as well. But like I was just saying, so here it's having me start at 0. So I'm actually going to be reading these inside numbers when I make this angle. And I can go, like I said, this would be 90. This is my right angle. I'm going to go over here to 180, which is pretty cool because the 180 has 180 on both, the inside and the outside portion. But I can actually go past that with this one, and I can go. There's my 270, and I can do here. I can go all the way. I can do a 300-degree angle, which I started here and I went all the way around. And so this type of protractor just lets you do, really, really large angles like that. But like I said, we're going to practice just within the 180-degree range today. So I've drawn an angle here. I'm going to get my protractor out, okay, to help us with measuring it. And so when we have a protractor, like I said before, you're gonna, your angle has 2 rays, and so you're gonna want to choose the ray that's gonna be easiest to line up with the bottom of your protractor. So I wouldn't choose this ray because then that would mean I'd have to, rotate my protractor around and all that stuff. This ray is already pretty flat and horizontal, so I'm gonna choose that one to line up my protractor with. So remember that middle point I pointed out earlier, okay, my vertex of my angle is gonna go here. And then I'm going to make sure that that bottom ray I chose lines up with the 0-degree mark. Okay, so here's 0 degrees, and my vertex is lined up here. So I'm ready to measure this angle. And you're probably thinking, but it says 180 degrees out here. So wherever I'm starting from, you always start measuring your angle from 0. Okay, and so. And like I said before, the way that the protractors are made, they're meant for you to be able to use either way. So let's say that this angle was flipped and it was, going in the other direction. I could measure it that way as well and not have to flip my protractor around because it does have a 0 over here also. Okay, but since it's pointing in this direction, I'm going to use this inside numbers, the inside numbers here, and I'm going to measure starting at 0. The other thing is, looking at this angle, I can tell that it's not a right angle and I can tell that it's less than 90 degrees. It looks smaller than a right angle. So I know that this is an acute angle. And if if we remember from our previous lesson, okay, an acute angle means that it's going to be, that was horrible. Let me write that again. Sorry, I just went and I typed it out because it was not working for my mouse. So remember that an acute angle means that it measures less than 90 degrees. So when I'm measuring with my protractor, I need to keep in mind that whatever answer I get here, it needs to be smaller than 90. And so that will also help you with making sure that you're using the right track of numbers to measure your angle, because if I'm thinking this is acute and if I'm getting, 130 or something like that for my measurement, then I know I've measured wrong and I need to go back and I need to use the other track of numbers on the protractor. So let's take a look. So I've got, my base ray is lined up with 0, my vertex is at the midpoint. And so now I'm just going to use the other ray to help me measure. And so I can actually kind of mimic this angle on my protractor. I'll extend it all the way. And so that looks about where my angle is pointing. And so if I were, now this protractor is kind of fancy and it actually, tells us the numbers here in the middle. Okay, I can see that this is extending, okay, remember using the inside track, so, it's past all these numbers here. So when I get to 70, I'm going to just count the individual lines. So this would be 70, this longer line. I wish my pointer wouldn't keep switching. And so then if I count all the individual marks, 71, 72, 73, then the part where the arrow is at would be 74. I think I can actually, I was playing around with this earlier and seeing, oh, there we go. So here it actually takes the angle out so we can see it separately. And it even tells us the measurement. So this is a 74-degree angle that I had created. It is acute, and so it's measuring as less than 90 degrees. So that everything there checks out. Because if I had made the mistake, if I used the outside band of numbers, well, for starters, it'd be really confusing because you'd be counting backwards, and we don't count backwards when we measure typically. And so you'd probably, get confused as to which way you're going up here. So it really should just make sense that you're counting in order gradually and you're starting from 0. Remember, we always, start from 0 when we are counting. All right. So I have another angle here, and we're going to get our protractor out again. All right. And we're going to measure this angle. And so now this is what I was talking about before. This angle is starting from the other direction. So I'm just going to click back real fast. So this angle, remember, the ray was pointing to the right. And in this angle, this base ray here is pointing to the left. So we're actually going to measure this one using the other set of numbers. So I'm going to first, again, here's my protractor. I'm going to line it up. As I already mentioned, this is going to be my base ray just because it's nice and horizontal and don't have to move things around to get it lined up. So my center point, my vertex is lined up here, and my base ray, okay, is lined up pretty good, 0. All right, and so remember last time we measured, from this part here, this 0. This time we're going to measure from this 0. Okay, so we're going to use the outside band of numbers for this one. Okay, and if let me take this off real fast so we can kind of look at it. So if we looked at this, remembering from our previous lessons, we would call this an obtuse angle. So we know that it has to measure somewhere in between 90 and 180 degrees. So if we get anything less than 90 degrees, we know that we've measured it wrong. So let's bring our protractor back and see what we get. So lining it up, zeroing it out. All right, looking good. So again, we're going to use these outside numbers. We're going to start at the 0 and we're going to go around. Okay, we're going to pass 90 as we should because we said that this was an obtuse angle. And we're going to keep going, 10, 20, 30, 40, 50. Okay, it's not quite to the 160. It looks pretty much, in between. I wasn't using a protractor when I made these angles. So if it doesn't line up exactly, we can always, round it to the nearest degree because it's kind of like in between those lines there. So 150, 151, 152, 153, 154. It looks pretty well lined up with that middle line there. So I could actually say that this angle measures 155 degrees, which would make sense because we said it was obtuse. And so 155 is in between that 90 and 180 range, so that checks out. And so your activity today, you have 2 choices. If you're not able to print out a protractor or get your hands on one, you can do the IXL lesson, which is Z.4, and that will have you practice measuring angles with a protractor digitally. Or if you get your hands on a protractor, or I have a printable one that you can print and cut out, then you can just practice, measuring angles at home. Draw some angles. You might, find naturally occurring angles and maybe some furniture or things like that, and just go around and practice measuring them using the protractor. So that's it for today, and I'll talk to you later. Bye.